Up next is Matt Wessel.
While she's doing that, I'll just let you know that we have PyMol now out on the iPad. We've had it out for a while from Schrödinger. It's free. Just go to iTunes, and you can get it for the iPad. I think you can get it for the iPhone, too, although that's pretty small. It works. Okay, so I'm going to talk to you a little bit today about actual drug discovery project that we ran in collaboration with Nimbus and the role that Seurat, our cheminformatics tool, played in that. And as you know, or may not know, Seurat is our tool that's based primarily on the ChemAxon tools under the hood. So its foundation is ChemAxon, and then we've expanded upon that and introduced a lot of additional Schrödinger technology to it as well. So the Nimbus approach, the Nimbus Discovery is the company that we collaborated with, is they basically worked on some prior targets that the industry had gone after and not gone after successfully because they're very difficult targets. One in particular, IRAC4, which I'll talk briefly about. This company is a virtual company, about 10 people in Boston, and they all do all of their chemistry outsourced to China. All the biological screening is done in China, and then the results are shipped back. And that's where Seurat comes in, because Seurat was the data management tool that they used. It's a really innovative partnering model, and there's a website. If you're interested, you could find out more about them. They basically told all of their investors that they would get to POC, in vivo POC, in 12 months, and they did. So what was started was a virtual screening of 1.3 million compounds with Glide using the DDAG group within Schrödinger. That's basically our CompChem for hire group. 300 plus compounds were chosen from that, and those were screened, and one compound was an 8 micromolar compound. A few months later, after 3,000 ideas were generated, 40 compounds were chosen for synthesis, got them down to 100 nanomolar, and then after 60,000 ideas were screened and looked at, only 271 compounds were chosen for synthesis, and that got them down to less than 10 nanomolar. So they were able to get to their in vivo POC in less than a year. And what is the number there? 311 compounds, something like that. It's pretty good. So what was the role that Seurat played? Well, it was their decision support environment, basically. So with Seurat, data access is really easy. It's facile. It connects to any number of databases that you might have internally. What you're actually looking at here is, I can get the mouse to come up, maybe I can't. What you're actually looking at here is actual IRAC4 IC50 data against that particular target, and then predicted potency based on a binding score, so kcals per mole, and you can see that there is actually a correlation. So this was based on glide docking. But you see this data side by side in Seurat, because the data from the virtual experiments was put into a database that was accessed by Seurat side by side with real data and assay results. Also, what you see here is links to docked Maestro file, docked poses, so that you can just pull those links down and look at the compounds in Maestro, or PyMol, perhaps, on your iPad for free. So Seurat's role at Nimbus was really interesting in the sense that they use this for live reports. So you can have in Seurat numerous reports that you've created through queries and stored and share with others. You can have your reports, you can have project-based reports, and then other people that are Seurat users, such as CROs, other organizations, other people within your organization, that some are in Portland, some are in New York, some are in Boston, they can look at those reports by just launching the application. You just double click on something and it takes you right to that live report right there. One thing that I wanted to touch on is that we created this for the Nimbus project, was this idea of a virtual space and a real space. So if you start with a compound idea, what you would do is you do a bunch of chemistry modeling on that. Computational chemists would look at the compound, dock it, score it, run a bunch of property calculations, et cetera. But they would track all of that information in an actual database as if it were a registered compound. So we created a virtual database for the Nimbus Corporation that had 70,000 compounds in it at one point. These are all compounds in what we call the idea database. Then ideas were filtered, ideas were looked at, and if an idea was selected for synthesis, it would go to outsourcing for synthesis, and when it came back, it would get registered into the actual real database. Right now, that real database, probably around 2,000 compounds now, but at the time that I made these slides, it was around 1,000 compounds. That was it. That was all they had screened or synthesized out of the 70,000 ideas. When that happens, a check is done to see where is that structure in the ideas database. If it actually exists in there, and a lot of them do, automatically transfer that data over to the real database, and that's how it's very easy to have data side by side between the real compounds and the actual virtual compounds. So that's how we actually achieve that through an automated process, by just having two different databases set up. We could work with any Seurat customer currently to actually enable this technology. Another important thing for project progression within the Nimbus collaboration was that R group analysis is really easy to do in Seurat. You have a list of compounds that have activity. They have a common scaffold. You deconvolute them into your R1 and R2 that you see here. And what you see, the little tables, that's actual real data. So those are real compounds with real data. And then what you see in the rest of the cells where there's structures, those are virtual enumerated structures. And what we're working on currently to add this to Seurat, hopefully very soon, perfect timing, is this add data feature where we could add in data to the virtual set of compounds. If you wanted, you could add in data to the real set of compounds too by looking at, by pulling back assay information. But we're going to be able to also add property calculations, glide doc scores, things of that nature, so that you can bring that data right back into this SAR matrix for the virtual compounds. And then you could presume that this is some sort of color coding based on log P or a glide score or something like that. So now you have much better coloration, organization, and filtering, et cetera, so that you can really narrow down to those compounds that you care about relative to that R group space that you've deconvoluted from your data set. So that's what's coming. That's one of the things that's coming, along with a lot of other things. Stop by our booth, like everybody says outside, and learn more about Seurat, learn more about Schrödinger. There's 3 of us here, myself, John Dowling, and Elise Axman, so please stop by. And just like to thank these people from Nimbus, these people from Schrödinger, including James and Scott. And Scott Becker, he used to be at a company called Invite Media. He was the CEO there, and that got purchased by Google for, I don't know, 81 million or something like that. And so now he's working for us, so it's great. Anyway, and by the way, I'm a Seahawks fan, and we really did not win last night. Thank you.